Hi children and viewers. Hi children and viewers. In previous video, I explained the series combination of resistors. Series combination of resistors as part of the combination of resistors. Now I am going to explain parallel combination of resistors in this video. Up to now you didn't see that particular series combination of resistors. You must watch it. I will provide the link of that video in the description of this video. Clear children? So don't forget to watch that. This is also one of the important topic. So children, in this video I am going to explain about what it is as part of combination of resistors. In that, what you have to discuss as parallel combination of resistors. This is the topic for today. Parallel combination of resistors. Children, I already told you what's that. When certain number of resistors are required in our laboratory or in any circuit, then those resistors are arranged in two ways. That is, first one is series combination of resistors and second one is parallel combination of resistors. In title only we have entire story, combination of resistors. That means what? We are going to use more number of resistors. Okay, so in previous video I clearly explained about how the resistors are arranged in series. Now let us go for parallel combination of resistors. So children, here now we are taken three resistors. This is the first resistor. I already told you the circuit symbol of resistor is like hills. It is like hills. So this is the circuit symbol of resistance or resistor. Circuit symbol of resistor. So that's why I am drawing this like this. This is the first resistor of resistance value R1. Clear children? And we have taken another resistor of resistance value R2. And this is the third resistor of resistance value R3. Clear? R1, R2, this is what? R2. And this is the R1. Three resistors we are taken. They are having some values R1, R2, R3. Now let us see how they can connect it in parallel. So I told you already, if it is a resistor, this is what we call first end of the resistor, and this is the second end. First end or second end. First end, second, and it is also called as like first terminal, second terminal. Clear? So children, now in parallel combination, here first end, and this is what? Second end, second end, second end. Here all first ends are given to 1 point. Clear children? First end of the first resistor, first end of the second resistor, and first end of the third resistor. They should be given to 1 point. Clear? Similarly, second end of the first resistor and second end of the second resistor and second end of the third resistor. These are given to the another point. These are given to the another point. Clear? Like this. So for example, I am saying now this is the A and this is the B. Clear? From these 2 points or in between these 2 points, battery is connected in parallel to the all resistors. like this. Across the 2 points A and B, one battery is connected. One battery is connected. That is called parallel combination of resistors. Simply, first all given resistors are arranged in parallel, one above the another, like that. So here all the first ends of the resistor are given to the one point, and all the second ends of the resistors are given to the another point. In between these two, one battery is connected. Now it is called parallel combination of resistors. Clear, children? Very simple. First all the resistors are given, they should be arranged in parallel, and after that what you have to say, all first ends are given to the one point and all second ends of the resistors are given to the another point. In between these two, we have to give one battery. That is what we call S, parallel combination of resistors. And children, now here I am saying that this is the P and this is now Q, higher potential and lower potential. In this one I am showing the V is the applied potential. What is that? V is the applied potential, and here the current is passes through the circuit like this. The arrows can represent the like this. Here at the point A, the I current is splits into like this: I1, I2 and I3. So I amount of current is coming from the battery. When it reaches the junction A or point A, that current is splits into the three paths. Then I1, I2, I3. So I1 amount of current is passes through the R1, and I2 current is passes through the R2, and I3 current is passes through the third resistor. Finally, at the point B, they will meet again. That should be coming like this current I. Clear? I amount of current is splits into three paths. After coming through the R1, R2, R3, again this becomes as I at the point B. So this is the direction of current flow in parallel combination of resistors. So that's why what you have to, children, according to Kirchhoff laws, what we write at the junction A, what you have to write simply the amount of current what it is supplied by the battery, that should be splits into the three paths. That's why here the amount of current I, the amount of current I, that should be splits into three paths. And again the amount of currents also in different in magnitudes. Clear? Now some of these currents are called equals to the amount of current supplied by the battery. That's why here net current is nothing but here algebraic sum of individual currents across the every resistor. So this is the first point, important point you have to remember. Clear? The current supplied by the battery is equals to the amount of sum of the currents passes through across the every resistor. I1 is what? Amount of current across the first resistor, and I2 is what? Amount of current across the second resistor, and I3 is what? Amount of current passes through the third resistor. So I is equals to I1 plus I2 plus I3. Amount of current sent by the battery is equals to the sum of the currents which are passes through the all resistors. Like I is equals to I1 plus I2 plus I3. In series combination, the current is moving in only one path. That's why there the current is constant. Clear? And second point you have to remember in this case, here in this combination, V is equals to V1 is equals to V2 is equals to V3. This is the second important point you have to remember. So all first ends are given to the positive. Clear? All in parallel combination, what do you observe, children? This one is given to the first end of the first resistor, first end of the second resistor, and first end of the third resistor. They given to one point. From that point only we are given to the positive of the battery. That's why here next one, second end of the first resistor, second end of the second resistor, and second end of the third resistor. They should be given to the second point, one point. That point is given to the negative terminal of the battery. That's why the potential across the every resistor is same as the applied potential. That's the reason. In parallel combination, what we have to remember, children? The potential across the every resistor is same as applied potential. Because the connection should be like that. All first ends are given to the positive of battery, all second ends are given to the negative of the battery. Clear, children? That's why what do you say? V is equals to V1 is equals to V2 is equals to V3. So you have to remember these two things, very important. Then only the derivation is in a correct way. Otherwise the derivation is wrong. Here I is equals to I1 plus I2 plus I3, and V is equals to V1, V2, V3. And children, already we know that what to write? V is equals to IR. This is what? Effective potential, and this is what? Net current, and this is what? Equivalent resistance. V is equals to IR. So equivalent potential can be written as V is equals to IR. Then from that what to write, children? I is equals to V by R. I is equals to V by R. I is equals to V by R. Now what is I? Total amount of current through the circuit or net amount of current through the circuit. I is equals to V by R. Similarly, by using this relation, we have to write current passing through R1. How we can write? First resistor, what do you write? I1 is equals to V1 by R1. And I2 is similarly the current passes through the second resistor. What is that? I2 is equals to V2 by R2. Clear? I is equals to V by R. Similarly, I1 is equals to V1 by R1, and I2 is equals to V2 by R2, and I3 is equals to V3 by R3. So similarly here, for third resistor, what do you write? I3 is equals to V3 by R3. V3 by R3. So now already we have values for I, I1, I2, I3. Now we have to substitute the I value, I1 value, I2 value, and I3 value in equation number 1. So we are going to substitute that. So children, what is the I here? What do you have? S, V by R. V by R is equals to I1. What is I1? V1 by R1. V1 by R1 plus V2 by I2 value is what? V2 by R2. And similarly, V3 value is, I3 value is what? V3 by R3. And children, what I told you? V is equals to V1 and V2 is equals to V and V3 is equals to V. That's why I am writing here V by R is equals to V by R1 plus V by R2 plus and V by R3. V by R3. So take common here. V by R is equals to V into 1 by R1 plus 1 by R2 plus 1 by R3. So V gets cancelled, then what do you get? 1 by R is equals to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the now expression for effective resistance in the parallel combination. What is children? 1 by R is equals to 1 by R1 plus 1 by R2 plus 1 by R3. So children, that is the expression for equivalent resistance in parallel combination of resistors. So here just see once, children, see again, we are taken three resistors, their values of resistance are R1, R2, R3. How they connected in parallel? Very simple. In parallel combination, first all should be arranged like this. After that, what you have to say, all the first ends of the resistors are given to one point, and all the second ends of the all resistors given to the another point B. In between these two, we have to give one battery. We have to give one battery. Clear? So when it is given in battery like this, then the potential across the every resistor is same as the applied potential. That's why we have to write V1 is equals to V2 is equals to V2 is, and that is equals to V3. And children, now we have another point. It is there, the I amount of current is passed through circuit. Once it can reaches the point A, that should be splits into like three parts, 1, 2, 3. That's why we have to assume that I1 amount of current is passes through the first resistor, and I2 amount of current is passed through the second resistor, and I3 amount of current is passes through the third resistor. So again, after reaching the B, again they should be combined, and it becomes as again I. That's why here we will write I is equals to I1 plus I2 plus I3. So by using these two relations, we have to derive the equation. So here already we know that from Ohm's law, what you write, I is equals to VR. So this is I is what? Total amount of current in the circuit. By using that, we have to write the amount of current passed through the first resistor is I1 is equals to V1 by R1, and amount of current passes through the second resistor is I2 is equals to V2 by R2, and third resistor is V3 by R3. Clear, children? So by substituting all the values in equation number 1, like this, we will get V by R is equals to V1 by R1 plus V2 by R2 plus V3 by R3. And already we know that what's that from equation number 2, V is equals to V1 and V is equals to V2 and V is equals to V3. That's why we will write like this, V by R is equals to, and like that. So finally what we get, 1 by R is equals to 1 by R1 plus 1 by R2 plus 1 by R3, children. So children, now in competitive exams or other anything exams, you have to remember few things. The first thing is here, this one, and second one is this one. V is equals to V1, V2 that is V3. This is the second one. And children, now in parallel combination, if you will take some R1 is equals to 2 and R2 is equals to some 4 and R3 is equals to 10 ohms. 2 ohms, 4 ohms and 10 ohms like that. So then we will consider like that. In that combination, how we can write the value? 1 by R is equals to 1 by 2 plus 1 by 4 plus 1 by 10. If you can do the calculations, then the R value must be less than the least value of the combination. In that combination of 2, 4, 10, what is the least value? 2. So that's why here the value what we are getting, the equivalent value in parallel combination, that value of combination mean the value of resistance or the value of equivalent resistance, that should be less than the least value of resistance in that combination. That is the third point you have to remember. The effective resistance value should be less than the least value of that combination. And next thing, children, for example here in any 2 marks question should be like this. Simply you are given 1 by R is equals to 1 by R1 plus 1 by R2 like that. Only 2 resistors are given, 2 ohms and 4 ohms. We are taking some, this is the R1 and R2. So you can directly, I am writing here 1 by R is equals to what, children? R2 plus R1 by R1 R2. So then what write? R is equals to what, right? R1 R2 by R1 plus R2. Simply here what you write? 1 by R is equals to R2 plus R1 by R1 R2. Then R is equals to what you write? R1 R2 by R1 plus R2. Simply what you write? R is equals to, R means this is combination what? Parallel combination. That's why I am writing here RP. RP is equals to R1 into R2. That means what? Product of resistances by R1 plus R2. That means what? Sum of resistances. Sum of resistances. Simply you can do very simply like this. When we have only two resistors, we will write like this. R is equals to R1 R2 by R1 plus R2. That means here R1 R2 production multiplication, R1 plus R2 addition. Then what write? RP is equals to product of resistance values by sum of the resistance values. You can use that. Then simplification is very easy. And next thing, fourth point you have to remember, and that is here we are taking n number of resistors. N number of resistors. If you can take n number of resistors, then simply here we are taking some n number of resistors like R1, R2, R3 and so on Rn and so on Rn. Rn. So then what write? 1 by R is equals to 1 by R1 plus 1 by R2 plus and so on 1 by Rn. That is the formula. And children, if those resistors have same value of resistance, then how we can write? Then I am writing Rp here because it is parallel combination. Then what is children? 1 by R plus 1 by R plus and so on 1 by R. Then what is children? 1 by Rp is equals to what, right? N by R. 1 plus 1 plus 1 like that. How many times? N number of times. N number of times. That's why here 1 by Rp is equals to N by R. Then Rp means what? R by N. So like this. When we have n number of resistors and their values are same, then we will directly go for the formula Rp is equals to R by N. Okay children, I already told you when the parallel combination is preferable, when the circuit is requires more current and least resistance value, then only the parallel combination is preferable. In series combination, when we can preferable? Series combination is preferable when the circuit requires more resistance and less current. Parallel combination is, yes, that should be preferable only when the circuit requires the more current and less or least resistance value. So children, this is about the parallel combination of resistors. So children, I hope you understand. If you can understand this video, like, share, comment the video and subscribe my channel for latest notifications and press the bell icon too. We will meet in the next video with some other interesting topic. Bye. Take care.